Okay, want us to continue with the rate of reaction. We are about to explain in details the factors which affect the rate of reaction using collagen theory. The first thing is we need to explain collagen theory. How does collagen theory work? But you need to note that when they ask you the questions in the exam, they will not need you to just explain collagen theory alone. You will need to explain factors that affect the rate of reaction using collagen theory. But we can talk about collagen theory alone. What does collagen theory say? Under collagen theory, we've got actually two types of collagen. We've got what we call effective collagen and ineffective collagen. Ineffective collagen. What is effective collagen? Effective collagen is a type of a collagen which results in the formation of new bonds and of new molecules. Molecules are going to break and the bonds are going to break and new bonds are going to be formed. That's effective collagen. Ineffective collagen, it means there's no formation of new bond. The collagen, it is ineffective, meaning it does not result in the formation of new molecules. It's like the reaction does not occur. There's no reaction that occurs with ineffective collagen. So that's the difference. So ineffective collagen, it results in it does not result in the formation of new bonds, meaning that two atoms are not going to react, rather molecules are not going to react. Effective collagen is when we break old bonds and we form new bonds. So what does collagen theory say? The first thing I can say, in order for a reaction to occur, molecules must collide effectively. What does it mean? When we talk about collision, we're talking about molecules just hitting against each other. As they hit against each other, all the bonds are going to be broken and there's going to be a formation of new bond. Like when we react hydrogen and oxygen. We've got hydrogen and oxygen. When they collide, they can form water, H2O. That's what we mean by effective collagen. But in a situation of ineffective collagen, we have got two atoms, just like these two things. They are colliding, hitting against each other, but it does not result in new bonds. You understand? That's what ineffective collagen. So collagen theory, it says that in order for a reaction to occur, molecules must collide effectively, which would result in the formation of new bonds. What is the other thing? Is that molecules must have enough kinetic energy in order to collide effectively. It means in order for a collision to occur, molecules must have what? The kinetic energy. Kinetic energy is the energy of movement. It means the molecules must have energy to move. so that they can collide, because they collide while they are in the state of movement. So that's what collision theory says. I won't say much about collision in general. These are the things that we are going to use to explain factors that affect the rate of reaction using the collision theory. Okay, as I'm done explaining the collision theory, let me explain those factors that affect the rate of reaction using collision theory. The factors that affect the rate of reaction, factors that affect rate of reaction, rate of reaction. The first factor, it is the surface area. It is the surface area. Second, it is the concentration. Then surface area concentration. Then we've got the catalyst. We can call the catalyst. We can add the nature of reactants. Let me put temperature here, because these three, the key, surface area concentration and temperature, they are keys, rather than I love them too much. Then here, let me just put a catalyst, then let me put the nature of reactants. Yes. So these are the factors that affect the rate of reaction. So we are going to use the collision theory to explain how each factor affects the rate of reaction. Let's talk about the surface area. What does surface area pertain? Surface area talks about the size. The surface area talks about the size, the space. So, for example, let's say we have got this space. I put 5 ideal molecules, ideally. You see here, this one has got the smaller surface area, this one has got the larger surface area. If these molecules that are inside, they were to collide, in which one between A and B will the collision be more harder? Isn't it to collide harder? But when molecules are closer to each other, they don't have enough space for them to collide. So surface area talks about space. You see here, the collision, the molecules are going to collide, but they are not going to collide harder because there is no enough space, enough surface area. Here, molecules are going to collide even more harder because there is enough space. So, how does the surface area affect the rate of reaction? It means when the surface area is larger, it means molecules have enough space to collide effectively. Remember that in order for a collision to occur that will result in the formation of new bond, the type of collision that must occur in that case, it must be the effective collision. So when the surface area is larger, it means molecules have enough space to collide effectively. And when they collide effectively, it will result in the formation of new bonds. And that means that the surface area is one of the factors that affect the rate of reaction. Remember, when we talk about the rate of reaction, we are talking about the speed at which the reaction is occurring. So it means the speed is going to be more faster when there is a larger surface area, because larger surface area it means that these molecules are going to have a space to collide effectively. It means the rate of reaction is going to be fast. Then, this is a secret. Don't share it with people. Here, I want to show you the second point when you explain about the factors that affect the rate of reaction. You write these two statements for all of them. You write the two statements here, 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 here. You repeat the same thing. So the only thing which will change for this one is surface area. When we talk about concentration, I will tell you what will change. But the two statements, because this one usually comes with 3 marks, 4 marks. So there are two statements which you must always write them because they are from collision theory. You need to write more effective collision per unit time. So it means when the surface area is larger, there's going to be more effective collision per unit time. This statement, you must always repeat it for all the factors that affect the rate of reaction. More effective collision per unit time. Then, the third one, there are many molecules with EK greater than EA. What does it mean? Many molecules with kinetic energy greater than activation energy. So since many molecules have got kinetic energy which is greater than activation energy, what does it mean? It means the molecules are going to collide effectively because they've got the energy to collide. So these two statements, you always repeat them. These two statements, you always repeat them. When we talk about surface area, it means the first statement for surface area is that surface area is going to increase the space at which the molecules are going to collide. Molecules have got enough space to collide effectively. Then the second thing is that there's going to be more effective collision per unit time. The third thing is that many molecules will have kinetic energy which is greater than activation energy. These two statements, you always repeat them for factors that affect the rate of reaction. Let us come to the second part, which is the concentration. You will notice that I don't erase these two because you always write them for each and every factor that affects the rate of reaction. So, what does concentration do? How does concentration affect the rate of reaction? Concentration is the measure of amount of solutes per unit volume of a solution. It's like when I have water, then I put maybe sugar inside the water. If I put a small amount of sugar, it means I have got small amount of concentration of the molecules of sugar. But when I increase the amount of sugar, it means I have what? Many molecules of sugar. It means I've increased the concentration of sugar in that water. You understand? So, it means concentration talks about the amount of molecules. So, when the concentration is increased, it means you have increased what? Molecules. This time around, you get to have many molecules. So, what does concentration do? Okay, just before I explain that, maybe you did not understand. Let's say I have two beakers. We're talking about concentration. Remember that in order for a reaction to occur, molecules must collide and effectively colliding like this. Let's say I have many molecules here. And don't confuse surface area and this concentration. Remember the example which I gave for surface area. They are more or less alike, but in terms of explanation, there's going to be different. Look at this one. Here there are many molecules. Here there are few molecules. This one, it has got many molecules. This one has got few molecules. Rather, let me just reduce them so that it becomes so clear to see that. This one I've got many, this one I've got only 4. This one, the concentration is high, concentration is low. So, since this one I've got many molecules, it means the chances for molecules to collide effectively are high. It is rare that the molecules are going to miss each other and not collide because the molecules are many. But for this one, chances are high that molecules can be moving around and this one can move and collide with the side wall of the container, without colliding with the other molecule. Because the molecules are few. It means this one is dilute. The concentration for this one is low. You understand? So when we increase the concentration, we're increasing chances for molecules to collide. It's like molecules are not going to miss each other, they're just going to collide because molecules are many. You understand? So that's how concentration affects the rate of reaction. It means when the concentration is high, what does it mean? It means we have increased the rate of reaction because there are many molecules with kinetic energy to collide effectively. It means that when we increase the concentration, what did we do? We have increased molecules with kinetic energy to collide effectively. Then it will result in the formation of new bond. Then what else? There will be more effective collision per unit time. Why do we have more effective collision per unit time? It's because we have increased the number of molecules with kinetic energy to collide effectively. So there will be more effective collision per unit time. Then what will happen? Since we have increased the molecules with kinetic energy, it means many molecules will have kinetic energy which is greater than activation energy. As I told you that for factors that affect rate of reaction, these two statements, you always write them. You always have 2 marks. If it's a factor that will affect the rate of reaction. Because each and every factor that affects the rate of reaction, in order to increase the rate of reaction, there must be more effective collision per unit time, and there must be many molecules with kinetic energy greater than activation energy. So this statement, you always repeat these two. You always repeat with 2. So you just have to know them. Then you know that for surface area, you write the 2 statement. For concentration, write the 2 statement. For temperature, write the 2 statement. For catalyst, you write the 2 statements. Then, I hope you understood how does concentration affect the rate of reaction. Then we come to the third one. Notice what I'm doing. I'm not erasing these 2 statements. Because they are always there. If the rate of reaction is fast, it's because what I wrote here has happened. It means there are more effective collision per unit time. It means many molecules have got kinetic energy greater than activation energy. Okay, let's talk about high temperature. Let's talk about high temperature, which is interesting. How does high temperature affect the rate of reaction? Okay, let me just give you an example of an ice. You know an ice. If you remove an ice from the deep freezer at home, take the ice and remove from the deep freezer, you put it in the environment. What will happen to the ice? The ice will start to melt. What is the chemistry that is there in the melting of the ice? This is what is happening. As the ice is inside the fridge, it means molecules are closely packed. Molecules are not moving. As you know, the ice inside the fridge is very hard. It is solid because molecules are not moving. They are closely packed and they are staying in one place. They are not moving. So as you increase the temperature, you move the ice from the deep freezer. It means if you remove the ice from the deep freezer, eventually you are increasing the temperature. Isn't it? In the deep freezer, the temperature is low. So if you move from the deep freezer, you are increasing the temperature. You put it in the environment. It means that ice is going to do what? It will be affected by the temperature of the environment. The temperature is increasing outside. Then what will happen? As temperature increases, the molecules that were closely pegged in the ice will start to shake a little bit. As the temperature increases, molecules will start to gain kinetic energy. Remember, kinetic energy is the energy of movement, right? So it means as the temperature is increasing on the ice, molecules will start to do what? To gain kinetic energy. They start to shake, they start to move. And molecules can move until you can't even see water. I'm not sure if you believe what I'm saying. You can have an ice, you put it inside a pan. You put the pan on the Bunsen burner. You light. Do you know that water can escape? Water can even move while it doesn't have legs because of an increase in temperature. It means that ice, the molecules that are holding it are going to move. As they move, because the temperature is increasing, they can end up escaping the container through evaporation. So it means when you increase temperature, you are causing molecules to move. Think about it. When you increase the temperature, the ice is going to melt. It become liquid phase. Then as you increase the temperature even more, what will happen? The ice will no longer have the ice. The water is going to become a vapor and it escape the container. After a while, you come and check the container, you find that there's nothing inside the container because increase in temperature causes molecules to gain kinetic energy, which is the energy of movement. So when you increase temperature, it means that what? Increase in temperature causes what? Molecules to gain kinetic energy and collide effectively. When you increase the temperature, you cause molecules to gain kinetic energy. Here is an ice. An ice is solid. There is no way the water molecules on an ice can escape and you find out there's no longer ice. But if you can take that ice, you put it in a pan, you increase the temperature by lighting a fire, then you'll find that water have escaped. It's because you have made the water molecule to gain kinetic energy through an increase in temperature. Kinetic energy is the energy of movement. You'll find that there is no longer water there inside the pan. Because you increase the temperature and you made water to do what? To escape the container. So it means, what did you do? When the temperature is high, molecules will gain kinetic energy and collide effectively. Then when molecules gain kinetic energy and collide effectively, what will happen? It means you'll have many molecules which have got high kinetic energy and are colliding effectively. What does it mean? It means that there will be more effective collision per unit time. Why do we have more effective collision per unit time? It's because molecules, they have gained the energy. So when molecules gain energy, it means they get to collide effectively. They frequently collide. They're colliding. Why are they colliding effectively? Why do we have many effective collision per unit time? It's because the molecules have gained kinetic energy because of high temperature. So temperature is a factor that can affect the rate of reaction. Temperature can cause the rate of reaction to be faster. So when you have a comparison whereby this reaction or this experiment have got a low temperature and this one have got a high temperature, it means the rate of reaction will be faster where there is a high temperature. Why do we have rate of reaction being faster where there is a high temperature? It's because molecules have gained kinetic energy, and when molecules gain kinetic energy, they get to collide. Many effective collision per unit time because molecules have got kinetic energy. Then we'll have many molecules with kinetic energy which is greater than activation energy. So these two statements, you always write them. For all factors that affect rate of reaction. So I usually advise people that when they write the things for chemistry, write in point form so that it is easy to see. Those who mark, they don't get to read a lot of things. They just see the point, they mark, they come to the point, they mark. So write in point form. The two statements, they are always there. They are always there. Okay, then let us talk about the last one, which is the catalyst. Catalyst. How does a catalyst increases the rate of reaction? The catalyst increases the rate of reaction by doing what? Remember, we know that we also do learn about catalysts in life sciences. We say they speed up chemical reaction. So a catalyst, yes, it speeds up rate of reaction. How does it speed up rate of reaction? Catalyst speed up rate of reaction. Let me say speed up reaction rate by lowering the activation energy. Catalyst speed up the rate of reaction by lowering activation energy. What is activation energy? Activation energy is the minimum amount of energy needed for a reaction to occur. So a catalyst speed up chemical reaction by lowering the activation energy. Let me give you an analogy. You find that yourself as a learner, you don't have a car. Why don't you have a car? While your parents are giving you money every day for lunchbox. Why? It is because a car is expensive. Even if they give you money every day, that money is not going to be able to buy a car because a car is expensive. That's why we don't have it. So I can liken that to a what? To a reaction which have got high activation energy. If the prices of cars can be 50 rands, it means even yourself you can have it. Even all learners can buy a car if it can be 50 rand, because the price it will have been made to be cheaper, so everyone can afford. So that's the work of a catalyst. You know what catalysts do? The prices of cars is high. The catalyst will come and make the prices of cars to be low. So when the prices of cars is low, it means everyone can afford. That's an analogy. Okay, don't go and write that. I'm just giving you an analogy. In physics, you write this. The catalyst will find a reaction which have got an activation energy. You find that the activation energy is 50 joules, is 50 kilojoules, right? Then when a catalyst comes there in that reaction, remember activation energy is the minimum amount of energy needed for a reaction to occur. So this reaction, it is not going to occur. It is not going to occur until that reaction have got 50 kilojoules. So it's like yourself, you won't buy a car until you have got 300,000. So what do we do if we want you to buy a car? We reduce the price of a car. If we reduce it, you're going to buy it. That's what the catalyst do. The catalyst will come and find that, oh, the activation energy is 50 kilojoules. Catalyst will come and will say that, oh, this reaction will not occur because to get 50 kilojoules, it will be difficult for this reaction. Let me make this reaction to be fast. The catalyst will come and reduce that initial 50 kilojoules and make it to be 20 kilojoules. You see, catalyst reduce the activation energy. Catalyst will reduce the activation energy. So since activation energy is reduced, it means it will be easy for a reaction to gather up 20 kilojoules, then the reaction is going to start. That's what a catalyst do. A catalyst reduces the activation energy. When activation energy is reduced, it means there's going to be what? There's going to be more effective collagen pairing time. And many molecules will have activation, will have kinetic energy which is greater than activation energy. Because activation energy will be less. Many kids in that analogy will start to buy cars. Why are they buying cars? Because the price is cheap. A car is 50 rand this time around. So everyone is going to go and buy car. Even your lunch box your parents give you can save it and you go and buy that 50 rand car because it is cheap. So it means the rate of reaction will be faster. Why is it faster? Because they've reduced the activation energy. In order for that reaction to be activated, it will no longer need 50 kilojoules, it will just need 20 kilojoules. So it will be easy to get 20 kilojoules, then the rate of reaction will be faster. There will be more effective collagen. So, as I told you that you write these statements all the time, I'm going to erase this and make a demonstration through a graphical representation. Let's take we have this graphical representation of endothermic reaction. Why is this reaction endothermic? It is endothermic because the energy of product is greater than energy of reactants. It means we started with reactants which have got low amount of energy. Then as the reaction came to an end, we come out with the product which have got more energy. It means we had less energy, we end with more energy. It means energy was gained in this system. That's why we start with small amount of energy and we end up with more amount of energy. This line represents the product, then this one represents the reactants, these lines, right? So here at the peak we call it activated complex. So the activation energy, it is this energy. You see, this energy, this amount of energy. Here we're going to have cause of reaction. Then here we're going to have amount of energy. Let's say we have numbers here: 20, 30, 40, 50, 60. 60, 70, you see? These energies that are in joules. So it means the reactants have got how much energy? 30. But they end up with what? The product, they've got 40. It means energy was gained. We have got 10 joule which was gained. So it means it's endothermic. Endothermic is a reaction whereby energy is gained in the system, in the reaction. You understand? So this is activation energy. You see how much energy is needed for that reaction to occur. So let me show you. Sometimes they ask you a question like, show us the effect of a catalyst. The catalyst will come and do this. You see this it's a mountain. Can you see this mountain? The catalyst will come and reduce this mountain. So you just draw dotted lines. These dotted lines. These dotted lines. You see, this mountain is no longer big, it is smaller. Why is it smaller? Because the catalyst have reduced the mountain. The mountain represents the activation energy. So catalyst, when catalysts come in, the catalyst will just destroy the mountain. The catalyst will just destroy the mountain. Catalyst will just reduce the what? The amount of energy that is needed for this reaction to occur. So the catalyst have reduced the what? The activation energy. So when they say they give you this type of a graphical representation, they say show us the effect of a catalyst. What do? You just draw a dotted line while you are doing what? While you are resembling this mountain, but you just reduce it. You reduce it. The mountain must be small. This peak, it must be small. You no longer you just reduce the peak. That is the effect of a catalyst. So when they activation energy is reduced, what will happen? We'll have many effective collagen per unit time. And we'll have many molecules with kinetic energy greater than activation energy. So I won't entertain this one much, but I can tell you about it, the nature of reactants. When we talk about the nature of reactants, we mean the type of reactants that we have. We have got some of the reactants which have got, in nature, they've got bonds which are easy to break. So since we've got bonds which are easy to break, it means it is easy to break those bonds and form new bonds. But we've got some atoms that it's difficult for them to react. You understand? So it means the rate of reaction is going to be slow for the type of an atom. Remember, I usually tell kids that when I say atom, I'm saying an element. That's a better way to understand. The word atom means an element in terms of explaining physics. So you find that I've got atoms that are naturally difficult to react. They are very difficult to react. So since they are very difficult to react in nature, it means the rate of reaction is going to be slow, because something that does not react faster, it means it is difficult, not easy. It is difficult to break its bond and form new kind of bonds. You understand? But atoms which are very reactive in nature, it means it's easy to break bonds and form new bonds, meaning the rate of reaction is going to be faster for the one which have got it have got reactivity, high reactivity in nature. So that's what it means, nature of reactants. It means the type of reactants that I'm going to use. Some reactants, they are unreactive in nature. Some reactants are reactive, natural so. So it means reactants that are reactive, natural so, the rate of reaction is going to be faster because naturally they are reactive. So expect the next video. Don't forget to subscribe to this channel, which teach grade 12 and 11 physical sciences from the high school perspective and the CAPS perspective using the exam guideline for the Department of Basic Education, South Africa. So be careful of just consuming everything that is in the internet, because in South Africa you are expected to use the exam guideline. When you explain certain things, you need to use the exam guideline. So it's not everything that uses the South African exam guideline. It's like physics is confined in that exam guideline in South Africa. So there are many ways you can explain this, but we are explaining this following the exam guideline. Although it does not end here, physics is complicated, sophisticated, but the exam guideline assists us on the scope of the things that we need to teach, because it's not everything that we need to teach at your level in grade 12 in South Africa. Thank God.